But what I observed yesterday is that the geometry was like divided into the like multiple parts. And although we use a shared topology, but somehow the solution was not converging properly. Okay, solution was not converging properly. So my suggestion is that in that case, because the difference between the workbench and the design model, the design model and the space claim is that in the space claim, they keep the different bodies there. They are connected internally. We have the continuous mesh, but they don't form a single body. They don't form a single part actually. In case of the design modeler, it can like have the multiple bodies, but it can create a single part. Okay. So that is like in this case, like we have the multiple boundaries there. We are defining multiple boundaries there. Same boundary, but we are having the multiple boundaries here because we have split the domain into two parts. The top bound, outer domain was divided into two parts. So it was actually splitting the boundary condition of the two parts. And that is making a problem. Somehow I don't know why it is making problem, but it is making problem. So my suggestion is that I delete the like something everything from here, okay, and right click here and reset. I will keep the same settings there like in the meshing and setup, but I will go for the new geometry. Okay, this will be very quick actually. It will not take more time.
Okay.
So from yesterday's class, you can know that how to make the geometry in the space claim. And from today's class, you can find out how to find the how to get the geometry in the design model. And I'm sure that you will see this thing that this is much easier to work in the design model for these cases. Okay. Sometimes when we are actually repairing geometry or making the domains like extracting fluid volume for internal geometries, the enclosure around the external aerodynamics flow analysis, in that case, space claim is much better. Okay. But when you are going for the creation of geometry, that is the like we either we should use some CAD software or we should go for the like a mini CAD software, which is a design modeler. Okay. So choose XY plane and go to sketching mode and click on look at also and make a one circle. Okay. So I will put the dimension here. And this circle dimension is going to be equal to the how much? The diameter of the tank. That is equal to the 0.01414. Okay. So we have the option to put the dimension directly in the 0.01414. Okay, but I would suggest one thing that because we have a lot of numbers of decimal places, this can make the problem. So first we are going to like move dimensions to the inside. Okay, like this. Close to the geometry. Actually, anything like we see in the windows, every number has a precision. Every number has everything as a precision. So if you take a look here on the tools and the options, we have the some length tolerance, which is like in the meter, this is like this much. Okay. In that case, we are okay with these dimensions. If there are like we have the length tolerance only is like three different places, then we are in the trouble. So I would suggest that whenever they are very small dimensions, we should change the dimensions to the millimeters. Okay, because default tolerance for millimeters will be way below than the what we are going to actually model there. So my suggestion is that we should go for the millimeters, but for this case already we have the like a lot of tolerances already set there. But if you reset, you see this is like 1, 2, 3, 4, 5. So here number is 1, 2, 3, 4, 5. Okay, this number will be okay. But if there's some number that is like having the 6 places, then we have the trouble. So I would suggest that we should change the units to the millimeters. Okay. But problem is that in design model, you feel like start when you start your geometry, you should set the units. So I will start over. Click here. First thing I will do is the units. I will change them to millimeters. Okay. Now choose XY plane. Click on look at and create a sketch. Okay. So now we are okay. So now I'm going to Okay, sorry. We should see the symbol P. Okay. Okay, now put the dimensions here. Okay, here the dimension for the equivalent to the, okay, let me close these all files. So dimension here is the 0.01414, okay? So multiply by 1000. The 14.14 millimeters, okay? So 14.14 millimeters. Now, if we take a look here now again on the options and the length tolerance, this is still in the meters is the same, okay? So, but we are okay here. We are okay here. So 14.14. Okay, then we have to use extrude command. And we should extrude by the how much distance? The height of tank is equal to the 0.0257. So calculate 0.0257 into 1000. So 25.7. So 25.7. Okay, click on generate. Okay, then on the bottom, we have the like orifice here. So I will be selecting the this bottom here. Okay. And I will be clicking on the like new sketch here. So now to make the sketch here, you can actually go to XY plane and then click on the new sketch and go back to the sketching mode. So click on the sketch number 2 and go to the sketching mode. Okay. Now draw our small circle here. Draw a small circle here. So a small circle here and dimensions here are, so this is going to be diameter. Okay, so dimensions for small circle or orifice is equal to the 0.002 meters. So 0.002 meters into 1000 is equal to 2 millimeters. Okay, so we are going to put the dimension as 2 millimeters. And then from the, go to the molding tab, click on the sketch 2 and click on the, like you can now use the two options here. We can use the extrude command and here you can actually use the imprint faces, click on generate. So actually we can directly get the one extra face here. Here.
Yeah.
Okay, this will be like a separate boundary. Before that, it was like a single surface. Now we have the two separate bodies, separate surface. So we can define this boundary as a pressure outlet for the orifice. But I would suggest that we can like modify this thing a little bit, and we can put something like a small pipe here. So this will be like a same size of the orifice, but we can extend the length by some distance here.
Yeah.
Okay.
Yeah.
Something extra we are going to do here. Okay, same thing will be happen there, but this
Yeah,
will
I
make
understand.
the things little bit complicated from the geometry point of view and also from meshing point of view. You're okay with this thing?
Yeah, yeah, I'm familiar with this. Yeah, yeah, it's okay. Yeah.
Okay, so just change the instead of the imprint faces, just change the operation to the add material. Simple. Okay, and then you have to put the direction here. Direction would be the, so direction vector is normal to the XY plane. Sorry, this one. So direction vector will be the normal to the XY plane, this one. So make it direction should be now, should go not inside geometry, but should go below here. Okay. So click on the this direction. It will now give you the second direction, upper direction. So actually instead of going inside, it is going outside the geometry. And the dimension I'm going to put will be the equal to the how much? Extend type is 2 next to make it fixed one. Okay. So I'm going to put the 5 millimeters maybe here. Or maybe less than the 5, maybe make it 3. Okay. So you can click on generate. So we have the extra part actually here with the extra part here. Okay. But the thing is that what I want here is that I need actually two things here. The first thing is that I would be doing it. I need the one extra pipe inside because I want to apply the multi-zone meshing there. So I need the one pipe that should be going throughout the circular cylinder. Actually, I want to divide the circular cylinder in two parts. Okay. So I'm going to use this option that is the slice material. Okay. And direction would be actually to the opposite side. It should go inside, and it should be extend type should be the to the through all, means that it be through all this geometry. Okay, and it will slice the material. So click on generate. You can see now we have the two bodies. One body is this one, and one body is this circular cylinder. Okay, so actually I can apply the swim meshing on this geometry, outside geometry. Inside geometry, I can make the hexa meshing with the help of the multi-zone meshing. Okay, that's why I made this decomposition in the geometry. Then I'm going to create the choose a face here, simple, this face. Okay, I will use the extrude command and I will do the same thing which we did before, but before we are going to get the extra pipe, actually what I want to do is that I want to get the first decomposition geometry, then I'm going to use the same geometry and make the new pipe. So apply, and this time I will be using the add frozen. Okay, and direction vector will be same, this one, apply, and the same dimension 3 mm, but this time this will be a separate part, separate geometry. So there will be three bodies. One body is the a circular cylinder minus the we have the inside this like a tube. Second, the tube that I'm going to use for the multi-zone meshing, and the one extra pipe that will be used for the exiting the flow from the tank through this orifice. Okay. Now to join them, actually, when we use the space claim to join the different parts and make the mesh like continuous across all the parts, we use shear topology. But in design modeler, instead of shear topology, we use form a new part. So we actually choose these three bodies and right click here and we click on the form new part. So this will become a single domain actually, but with the three bodies actually. So three bodies are there, and we can define the three different meshing there, meshing methods or types there. And mesh will be continuous, but we can specify the different things on different parts there. Okay.
Mm.
And the last thing is that we have to specify the boundary conditions. So on the top boundary, now benefit here is that the domain name will be single, name will be there. Number one, the domain name will be part here actually. And also the boundaries will be, the single boundary will be there. So we need to only specify the boundary condition for single boundary. Okay. There's no point having the half circle for this side and half circle for this side because it's a single boundary here. So that problem I'm facing in the space claim. Okay. So in that case, I thought that it's much better to use a design model as compared to space claim. Okay, so right click and click on name selection. And this is going to be my top boundary. It took not more than 15 minutes.
Yeah,
Okay,
yeah,
this is
it's okay.
my the wall boundary condition. Okay, this is my bottom boundary condition. Same boundary condition name I'm putting here also. Bottom, and this one is the wall. Let's say put the name as a wall. Okay, it's a wall orifice. And generate, and the last boundary is the orifice itself. This is going to be the name will be orifice and type will be the outlet that we define in the fluent, not here. Okay, so this is the orifice. So we can put the names here. We can put the names here for the boundaries, but to define the boundary type and the conditions, we use the fluent. Okay, so now we have the top boundary. We have the wall, the bottom boundary, the wall of the orifice pipe and the orifice itself. Okay. So you can save the project file. And I hope that we can use the already specified the meshing algorithm in the meshing app. Double click here.
Shared topology. Yeah.
Shared topology not required here actually.
Okay.
Okay, once we make a new part, we don't need the shared topology. Okay, first thing is that I'm going to, okay, few more operations we have to apply. Number one is that we have to actually divide this outside geometry into two parts. Otherwise, we will not be able to apply the sweep meshing. Okay, because we have to split the number of cells here, so we need to have the boundaries here. One here and one here. Just give me 1 minute, actually, please.
Okay. Yeah.
Okay, so we need these two edges where we can specify number of cells. And number two is that the sweep meshing actually works in this way that it requires a one surface, and that can sweep the mesh from that surface to the whole volume. Okay, so here we are not going to use a sweeping from this boundary to the bottom, but actually this time this will use circular sweeping. Okay, so the ANSYS meshing will create a one plane, like a normal plane here, vertical plane, and make the number of cells depending on the number of cells we specified here, and also on the vertical edges, and this will sweep the mesh along this geometry. And because we have the benefit of not having the geometry up to the center, so actually we can create the full hexa meshing very easily. Okay, so for that purpose, we have to divide geometry into these two pipes into two this outside cylinder into two parts. Okay. So I will use a slice command. So I will use create menu and slice operation. Okay. I will choose this body. Plane will be for this, you can use either the ZX plane, or you can use the YZ plane. It's your choice, actually. So let's use the YZ plane. And which the body is outside body, this body. Not all body, but this body. Okay, and click on generate. Okay, so you can observe here one thing, that once we apply the split command, the slice command, so inside this cylinder is not splitted, but still we have the boundaries here. This will be like a separate boundary. So this will be like a two edges inside the circle. But on the bottom circle, it's a single boundary. So we have to divide that thing also into the two parts here. So for that, again, I use the slice command, but sorry, I will not use slice command, but rather I will use the face split command. Okay. So I'm going to split this bottom face, and with the help of the plane, same plane. So by plane, and plane is going to be the YZ plane. So apply and click on generate. So I can now divide this one into the two surfaces. Okay. And from the view menu, you can remove the transparency in the body, frozen body transparency. And now you can see the things in this way. Okay. So let me hide one body from here, and then you can see from inside. So hide this body. and hide these faces. You can actually press the F8 key. Okay. You can see that actually we have the multiple edges are there. Edges here also. We have the edges here also. There will be actually two edges will be there. Not here, but on the vertical side. Okay, so we are done with this thing. Then we have to import the our new geometry here into meshing software. So you can right click on the model A3 and click on update geometry from source. Okay, so now you can see the like a wireframe view and select the any of the edges. See what happens here. So in the geometry it was not showing this is the two edges, but here you can see these are two edges here actually. Okay. So again, go back to the like 3D view and choose these two bodies and hide them, or you can suppress them for a time being. Okay. So I will use the multi-zone meshing on these two bodies. Inflation also on these two bodies and four boundaries. This surface, this surface, this surface, and this surface. And I will use a face meshing on this top and the bottom. So this is the same thing actually. Okay. Right now, I'm going to delete this edge sizing here because I don't know which size sizing is defined there and put in the wireframe view. Okay. So I'll define the edge sizing again from the scratch. So I'm going to choose these two edges for these six edges actually. And I'm going to put the number of elements to the 16 here. Okay. And okay, now I'm going to select the remaining boundaries. So right click here and select them again. And suppress. And here I'm going to put the sizing on these four vertical edges. So click on the mesh and then sizing. So I'm going to put the number of elements divisions here to be equal to maybe around 20. Okay. And also I have to put the biasing on the bottom side. So let's put the factor is equal to 15. So these two edges are giving me the proper biasing towards the bottom side, but these two are giving me the reverse biasing. So I have to use the reverse biasing option on these two edges and they will change the direction to the bottom side. Okay. In a similar way, like we did the meshing on these edges. Okay. So that's okay. You can also include the outer edges, but this is not required actually. Okay, now go ahead and okay, we have the edge sizing here, sizing here. Okay, last sizing will be on these edges. So I'm going to put the sizing on these edges also. Apply and number of elements, let's put them to be maybe 15. And we put the biasing here also. So use the reverse biasing on these edges, this edge and this edge. Okay, now you can generate the mesh. Simple. Okay, I want to play with the parameters of an inflation. So let's make the transition ratio as the 0.55 and the growth rate may be the 1.05. Okay, and click on generate. Okay, one more thing is that the element size change across the block is very large. So this is one thing. Second thing is that we can increase the number of cells on these edges, but I think this is not required here right now. So we can actually change the biasing ratio here on these edges. So let's make it 20. Okay, and again generate mesh. Now this is looks better. Okay, this looks better. Okay, on the vertical edges, you can see that the biasing is not taking effect as such. Yes. So we have to make the behavior as a hard for these edges. Okay. So go to the capture curvature and make it no. And then make the behavior as a hard. So this will be implemented as it is. And click on generate. Okay, sometimes because they are different algorithms working together, so sometimes some setting of meshing cannot work for the all parts. So you have to divide actually the generated mesh and create again. So it will start from the it should now the specified sizes will be defined first, and non-specified sizes will be defined later on. Okay. And sizing on this element, they are okay. So I will not change the biasing, or I will not put the any biasing actually on this edges here, vertical edges here. Okay. So I think the sizing is now okay. Okay, just check the number of elements there. So, sorry, here, not here, but from the statistics. So number of elements are 21,888, the number of cells. The quality is, the orthogonal quality is the minimum is a 0.82 and maximum is a 0.99. 0.1 is actually best quality, 0 is the worst quality. And the average quality is a 0.98. So almost all elements there are having the best quality actually, almost. Okay, last thing is that you have to click on the update. This will translate the mesh to the Fluent. Okay, and open the setup. And we have the already made all the settings there. I think there's no need to actually change anything at all. You can use rubber precision solver and click and start. Okay, because the previous mesh was different, so it is giving us some compatibility issues. Solution is that you have to go for the file menu and recorded mesh operations. Okay, so missing zones are these ones. So these two will be equivalent to the this part. Okay. So wall small is the wall orifice. Bottom is a bottom. Wall is a wall. And the top is a top. Okay. And apply. Our second way is that we can reset the all settings and we can start from the scratch. Okay, now you have to work on this one. Okay, delete these boundaries. So Actually, when you work in the like standalone mode of the Fluent, these problems doesn't arise. And right now, this Fluent is detecting the like a mesh from the previous case and also from the new case. That's why it is giving you the some options here. Okay. So again, the recorded mesh operations, wall small, and this is the wall orifice, bottom, bottom, wall and wall, top and top. Apply and okay. Okay, so display the geometry. So bottom is this one. Okay. Orifice is over here. Top boundary is here, and the wall is here. Wall small is on the bottom side. So I think everything is all right. Okay, so we have all the settings. So just confirm everything again. There should be two fluids. Okay, in the materials, we have the, actually, we are getting more errors. So I would suggest one thing. At this point, right click here and click on the reset. Okay. This will delete everything from there. And again, we read the new mesh file here and we have to make the settings again from the scratch. So make the double precision and the 4 processors and start. So we have to put these settings into the there. Okay. Any questions?
No, no, sir.
Okay. Oh, okay. So in the boundary conditions, we start with the like a very basic. So setup, transient, and gravity. In this case, gravity will be now in the like a negative z direction. Okay. So z is in the actually vertical direction z. So gravity will be in the negative z direction, minus 9.81. Okay, so it's a pressure based and transient, and gravity is a negative z direction, 9.81. So, okay, instead of doing this thing, I think we should put the thing negative z direction, and we should put the value here 9.81. Okay. Then in the materials, I am going to choose another material that is our water liquid. So from Fluent database, I will choose the water liquid and click on copy. This will become the part of the database in our current case. Okay, and then I will go to the models, and I will keep the default model for like a viscous, but you can like I did here in this case, in the slides here, I use the capsulon, lysable, and with the scalable value functions. Okay, so click on OK. And I told you the difference between the like a wall function, scalable wall function, enhanced wall treatment, y plus 30, y plus 1. So I think you know about these things. Okay. And then in the boundary conditions, I'm going to choose for the orifice, this is going to be the pressure outlet. And same goes with the top boundary. Okay. From top boundary, actually the air will go inside. This will be like a free surface. So I'm going to make the top boundary as the pressure outlet as well. Okay, and also I need to make the multi-phase model enabled, and this is going to be the volume of fluid, and click and apply. I will just keep the default settings there. In the phases, first phase, primary phase would be the lighter one, which is the air. So choose a name as the air and material as the air and click on apply. Secondary phase is the water, and make sure the phase material is the water liquid, okay? And click and apply. So we have the materials, air and water. We have the V of settings, they are done. We have the boundary conditions done also. The next thing is that we have to look for these things. So we go for the operating conditions. So physics menu, operating conditions. So we can see the gravity is in the Z direction. This should be the minus 9.81. Okay. And the operating density should be the minimum density that is of the air. So put that value and click on OK. Okay. Make sure this is a minus 8.9.81. Okay. In solid settings, we use the K epsilon as well with the square wall functions, and simple for the velocity pressure coupling. So same thing is here. Presto for the pressure, and reconstruct for the volume fraction. And for other schemes, this is the first order, and momentum is second order. And we initialize. So initialization is very important. So initialize with the default settings. Okay, so simply go to initialization and initialize. Okay. Then I will go to domains, and from here I will click on the manual operation, and I will be making a cell register that is going to be used for actually specifying the volume fraction in the whole tank. So I will choose a new region, and this is going to be the minus 0.0, half of the diameter, 0.07070. Okay. So same thing goes in the y direction also. Only thing is that this is the positive value and negative value. So negative will be the minimum value, positive is the maximum value. And in the Z, height is of the tank is the 0.257, if you remember. The tank height is the 0.0257. So 0.0257 and click on save display. Okay, so this volume is selected, and on this volume we are going to apply the volume fraction of water equal to be the 1. So I will go back to the initialization, and from here I will be now choosing the page command. So I'm going to page the my volume fraction here. Okay, so page, and region number 0, which we use here. Actually, we select this region number 0 here. Okay, and this is the water, and volume fraction is equal to 1. And click on the page command and close. Okay, and then we have to also put the animation. So we have to click here and click on solution animation. But before that, we have to create a actually new plane. So click on domain also. And from domain, or you can use the same thing from results menu also. So surface and create. So I want to create isosurface. So click here. So I want to actually make a one plane. vertical plane there where I want to show the like a volume fraction of the water and the air. So for that, I will choose the mesh and x coordinate is okay. Constant x coordinate will be okay. And value will be 0. Okay, this value 0 means that we are going to create a center plane. Okay, close. So new object will be the control plots of the volume fraction of the water. So I will use the phases and the volume fraction, and that is the water. And I'm going to use the x coordinate 5. Okay, click on save display. And the view is very important. You should select the proper view. So like you can make it like in this way. Okay, so let's put the name as this is the water tank VF. Okay, click on OK. And then in the run calculation, I'm going to put the time step that we calculated yesterday, which is the 0.011. And number of steps, I'm going to put the lot of steps here. Okay. And also in the monitors, we have to actually reduce the criteria for the solution convergence. So make it like a more zeros here, maybe the from 2 zeros to make them 5 or 6 zeros. Okay, so I was talking about what thing? Okay, residuals. So at least put the 2 zeros there. And click on OK. And now click on run calculation and calculate. Okay, we should be selecting the proper view. Okay, that's very important. So go back to solution animations. Okay, so we should select the like a proper view. Otherwise, we can have the default views, and that's not good thing. So I'm going to again go back to solution animations, and here I'm going to actually click on the manage views and choose my select say my this view, which is view number 0 right now. So view number 0, and in the animation view, I'm going to choose a view number 0. Okay, and click on OK. But I want to initialize again because this will not give me the whole animation. Maybe I'm going to miss the 2 or 3 frames from there. So I'm going to again initialize. Okay.
Hello, Professor.
Yes.
Ah,
Okay. So we initialize again. Okay. So we have to use the page command again. So water and volume fraction is equal to 1. Click on page and go back to calculations and again run the calculation. Okay. Can you see that we have the like a lever is going down in the tank? So if I stop the simulation here, okay. So we can go to the control the volume fraction, and from here click animation and solution playback. Okay. So right now we have the 80 frames. So you can like click on the play option. Okay. See it again. So initially the water is like there was air here. The air was exited from the bottom, and you can see the from here bottom here.
Yeah, Professor. Yeah. Hello,
Mm-hmm.
Professor. Yeah. No, no, you don't need to do
Yes,
that.
yes, please.
Yeah. Oh, one question. That's mean normally, if
Yes.
practically the when we emptying a tank, water tank, the phase phase interface is very sharp. That's mean no.
Yes, 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 yes. Clear. Right,
Yeah.
right, right.
What we
It
can
should
do
be
to
sure.
improve? You don't need to do, but I have.
You're correct actually that we should have the sharp interface, especially here. So because we have the like a very coarse mesh, and that's why
Mm,
we have the this problem occurring here. Okay. But if
thank
you
you.
go with the fine mesh, then the time step size will also be reduced. Might be.
Mm,
Probably
mm,
the time step size will also reduce because we have to keep the current number less than like a two, or maximum should be two, not more than two.
mm,
I would prefer that it should be like around one or less than one. In that case, as the size of the mesh reduces, and so the time step. So we have to go for the less time step. But for demonstration purpose, actually, I have to be compromising on the solution accuracy.
mm.
Okay.
Yeah, yeah. I thank you very
So
much. Yeah,
now, okay. So let's run this simulation like for few more time steps there. Okay. So, okay,
okay,
just
okay.
we give the 5 minutes to the iteration, and then we'll stop here. And then I will show you that how you can actually create the same animation in the CFD post.
Thank you.
Okay.
Professor.
Okay, sorry.
Okay. No, yeah, I can't hear.
Okay,
But
I was saying that we could put the like a different boundary condition. We can put the symmetry on the top, and the water we can go outside, and at the same time air will be trying to enter without because if the air cannot enter, it cannot fill the empty space. Water actually cannot go outside. It's the thing you can observe in case of any bottle. You can like make it upside down and try to exit the water from the like exit point of the bottle. You see that the some air will go inside. You will see the bubbles there. Okay, and then water can go outside. So I can put the symmetry condition on the top, and then I can, but this will take more time actually. This will take more time to empty. You can try out to the guessing that you can only put the one outlet here and nothing, no outlet on the top and the sides, and no inlet as well. Okay. So now we can now make the animation here. So right now we have the 160 time frames. You can play first here on the screen. Okay, so you can write down the animation file. And this file will be written in your working folder. So this working folder is here. The problem is that the geometry is 3D, but we are only looking at the volume fraction or tank drainage at the one plane. So if you see them on the 3D, you can see the like some interesting things may be happening there actually. Okay, so you can play the animation here. Okay, now let's make the like animation in the CFD post. Okay. So I'll duplicate here. I will keep the fluent settings as it is, they are there. And I want to now create the animations in the CFD post. Okay. So here, let's put the name as animation in CFD post. So again, you have to go to setup. So we have to start from the scratch. Okay. If you want to export the mesh, animation for the CFD post, then you have to set up everything from the very beginning. So that's why we're starting from the setup. The benefit of CFD post is that actually it offers the many options. We can display geometry also. We can have our own view right now, because whatever view is saved in the animation, that view will be there in the, like, if you want to make the video file. But the CFD post, we can actually create the any view. Okay. In the real time, we can use any view, and that will allow us. And also at the same time, we can also display the geometry. Okay, we should close the one Fluent window, because it is giving us the license problem. So it can only, I think, entertain only the one Fluent at the one time.
Oh,
Okay, for this to happen, we will doing that thing from the, actually from the calculation activities. Okay, and click on automatic export, click on create, and solution data export. Okay, from the file type, you have to choose a seed date for CFD post and insight. And let's put the name as the tank VOF. And here you have to choose the volume body and the cell zones. So there's no need to choose the X coordinate 5. And whatever variable you want to actually export here. So let's choose static pressure, total pressure, density, velocity magnitude, 3 velocity components, and also vorticity components, and turbulent quantities. These criteria for showing the vorticities, and Y plus, vol Y star, shear stresses quantities. Maybe you want to show them in your CFD post session, skin fraction coefficients, X, Y, Z coordinates, and then importantly, we have to export the volume fractions for the air and the water. Okay. And now click on OK. So this will write down the file after every one time step. So click on OK, click on run calculation, and click on calculate. Sorry, we have to actually initialize the solution. Okay, initialize, and then we have to use the register. If it is not there, then you have to create again for the second session also. But we have the already there, okay? And I will choose the water, and water fraction, volume fraction will be equal to 1. Click on page and then run the calculation again. So these file actually will be written now for the CFD post as well. Okay, are you able to see the screen?
Yeah.
Okay. Okay, we can stop here now. Okay.
Okay.
Okay, now let's start the CFD post. Okay. Okay, so we can stop here now. and we can close the app. Okay. Yesterday I was trying to do the same thing inside the CFD post, but somehow I don't know why we have to read the files directly in the CFD post. Not it is not taking the files from the full into the CFD post. So let's try again today. Maybe we can get it done. Okay. If not, then we have to like open the new CFD post and read the files we are saving right now. We are saving in the CDate files. Okay. What should be getting is that we should be getting the complete history of the all the time steps. But it is giving us a last time step. So it means that actually we have to use a separate CFD post here, results. Okay, double click here. For making animation in the CFD post, actually we should be having the all the time steps in the CFD post, and then we can make the animation. So go to file menu, click on load results, and we should go for this same folder here. Okay. So DP0 and triple F1. Okay, Fluent. And we need the CDAT files. CDAT files are the files for CFD post. Okay, CDAT files, and read the last file. Last file is the now right now we have done the 53 steps, the 53.cdat file, and click on open. Click on OK. Now take a look on the time steps. You can see we have the log like all the time steps with us from the first to the last. Okay. So then I will be choosing the animation here. Okay. Now just keep as it is. Okay. Now go for the one plane iso surface. So this is going to be the constant value of X and apply. Okay. So I will be hiding the plane because I want to only show the contour plots on this plane. So for that, I will be showing the contours, and on the location is going to be isosurface 1, and the variables will be the volume fraction of water. Okay, and range will be local. So this is going to be the solution at the very first time step. Okay, like this. Okay, so I'm going to use the keyframe animation. So first thing is that you have to click on the like a first frame. Uh, you have to click on the last time frame actually here. Okay. 1 minute. Okay, insert. And here, okay, you should be on the first time on the frame, but you have to put the number of frames equal to the last frame here. So which is equal to 53. So put it here. And then you have to like click on the last time step and put another frame here. So by default, they will be containing 10 frames here. That's okay. Okay, so now what you have to do is that actually we have to now save the movie, and where you have to select the path. So let's say I want to save the movie or the file in the E drive. Okay. And the file name I'm going to put is my tank VOF. Okay. And here you can make the speed slow or fast, right? So here you can play here, and if you go to there, you can actually save the file. So in the options, you can change the speed also. So slower, faster, normal. So by factor of 2, that's okay. Okay, just make it as a normal. Okay. And click on OK, and then click on the play. Now this will write down all the keyframes, and then from those keyframes, it will make the animation. Okay, the animation file. Now because we have the very less frames, yes, that's why animation is not that much interesting like we did in the Fluent, but we do have the animation. So that file name is the tank VF, and file type is the WMV. So you can double click here. Okay. Okay. One more thing is that then I will stop. Is that you can actually put the time here. So I can go into insert and text here. Okay. So you can put the enable auto annotation. So actually I can put the expression here. So let's say the expression name is the time. And I want to put the time here. So total time will be here and apply. Okay, so I have to make the new keyframe animations. So delete them. Okay, and before that I want to set the time location where it should be displayed. So in that I can actually have the appearance. 1 minute. Okay, so X justification is let's put the by ourselves, and same goes with the Y justification. So for X will be from side to side. Okay, so let's put it at the 0.5, and the Y I'm going to put it as a 0.3. Okay. Okay, or make it maybe 0.6, and X is equal to 0.35. Okay, so this is what we need here. Okay, and I can change the frame in this way. Okay, so again, we have to double click on the very first time step, make a new keyframe here, and number of frames will be 53, whatever they are there in the whole animation, 53. And then you have to click on the last time step and make a new frame here, and then you have to write down the file. So now you can see the time along with the animation. Okay, so now we have the time as well. Okay. Any questions?
No. Nice books.
Okay, so this is now completed. So last workshop is about the that is uh, wind turbine, 2D wind turbine. So there we start from tomorrow.
Okay, yeah. Thank you.
Okay, and we will be completing this workshop by this week.
Okay, thank you very
Okay.
much. Yeah.
Okay,
Thank you,
so
Prof.
I will send you all the video files through Google Drive link. And once I are done with that thing, then I will send you all the files which are up till now we have done the 4 projects. So I will send you all the files in the Google Drive. So first the videos and then these files.
Okay. Yeah,
Okay.
thank you.
Okay, see you tomorrow. Same
See
time.
you. See you.